I'm Professor Gibson, and this is the last of our 3 short videos that go along with our Excel project this semester. All right, so this one is simply called formulas. This is an outline here, so the first few topics are going to be about working with formulas and some things related to that in Excel. And then the last few are about some things that you're specifically going to be asked to do in the project. Okay, so let's click over here. To start off with, I'm going to enter some data. 18, 25, 22, 31, 12. There's 5 data values, right? Let's compute an average. So remember, to get a formula, we type equals, and then we're going to do an average. So to do an average, I got to add up all the numbers and divide by how many there are, right? There's 5 numbers. So I'm going to put in a parenthesis, click on the first number, click a plus. On the second number, click a plus, third plus, fourth plus, fifth. Now there is a built-in, and then we're going to do the close parenthesis. Now there's a built-in function that does this, that adds stuff up for you, but remember the instructions specifically say not to use built-in functions. All right, so now I've added them all up. I just need to divide by how many there are, which was 5. Slash for divide, 5, enter. All right, 21.6, there's my average. Now we're going to calculate something called a deviation. I'm picking this because it will allow me to show you some other things in Excel. The project doesn't use deviations. All right, so type an equal sign. Now what the deviation is each number in the data set minus the average. All right, so let's do the first one. Equals, click on the 18 to get that particular number, right? Minus, click on the average, enter. All right, so that first deviation is minus 3.6. That tells us that 18 is 3.6 below the average for the data set. All right, if I click on it, if you look up here, you see it says equals B3 minus B9, right? So column B, row 3 is the 18, column B, row 9 is the average, and B3 minus B9, okay? So let me show you now. Excel does some very cool stuff. What happens if I put the mouse pointer over the lower right corner? See the mouse pointer changes shape? Hold down with your left mouse and drag it down. Now, so up here it says B3 minus B9, it's the first one. When I drag it down, it now says B4 minus B10. In other words, when I dragged it down 1, it changed both references by moving them up by 1. And then this one says B5 minus B11. Well, the problem is that 10 and 11 are both blank, so that's not really very helpful. So I'll go back up to here, and what I'm going to do is I'm going to put a dollar sign in there right next to that 9, okay? The reason I'm putting it there, remember B9 is where the average is, right? What that dollar sign is going to do is that 9 is going to stay a 9 even as I drag it down, okay? So watch, I'll drag it and I'll drag it. See, when I get to the next cell, the 3 went up to a 4, but the 9 stayed. And then the next one, the 4 goes up to a 5, and the 9 stayed. What's happening now is the first number is changing, right? The cell reference for the first number changes to match my data just to the left, and then the last one stays locked into the average. That's just what I need, right? This is the deviation for each one of these. Now, another way you could do this, let's just take one and copy it. I'm going to right-click, copy, highlight the next two cells, paste. Okay? Notice, I'm going to click, did the same thing, right? We've gone to B6, the 9 still stayed 9. On to B7, the 9 still stayed 9. Okay? So you can drag them down, you can copy-paste them. What happens is the number that keeps changing is called as a relative reference. And that's the default. If you don't put a dollar sign in there, when you copy a formula, the formula will change by how you move it. Like, watch, let me show you something here. If I take this, copy, and I move 2 to the right, paste. Okay? Now it was in B, I moved 2 to the right. Now you see it says D and D. Right? Now it's 0 because D3 is blank and D9 is blank. Well, so that's 0 minus 0. Okay, so whichever way you move the cursor, right? Whichever way you copy it, the formula is going to move in that direction unless you have some dollar signs in there. Okay, let's have a look at the next one here. Drag the formulas, average deviations. So the instructions for the project say that you have to show the formulas for your work that are in Excel. For your answers in Excel, the formulas have to show. Okay, so what's meant by that? Like if you click here, if you do an average, we click there, you see how it's got the formula for the average? What it means is that you need to put the calculation, you need to use the Excel functions to do your calculations. You can't just figure out on a calculator, like this one's 21.6, you can't figure out the 21.6 in your calculator and just type it in. If I do that, watch what happens. I type 21.6, hit enter. Up here, it just says 21.6, right? Well, there's no formula there. You need to do it like this. You need to do the formulas in Excel so that your teacher can see that you used Excel to do it. Okay, the Excel project basically has two purposes. It's teaching you some mathematical stuff as well as how to use Excel. And so your questions that go in Excel, the formulas need to be there just like this. All right. Next, so recursive and explicit. Let's look at the linear growth one. So I put the formulas here. Again, these are right out of the book, so if you want them, you've probably got them written in your notes, but if you're not sure where they are, you could freeze this, pause this video for a minute and copy those down. Here's the formulas, recursive and explicit for linear, and recursive and explicit for exponential. So let's go back over to some data we had in the last video. This is my linear one, and I've already got a recursive formulas in here. Okay. And once you've got the right recursive formula in, if you grab it, right, let's talk about 4, get the mouse cursor in the lower right corner so it changes, grab it and drag down, then it'll get you your other data values. Recursive works great for Excel. What about explicit? Okay, well, if you remember how to do explicit, those will work too, okay? You can just type the explicit formula in. Now, the difference between a recursive and explicit, just kind of as a concept, is that recursive, to get one cell value, you use the previous cell value, all right, in a formula. For explicit, you use the X, which in our case is this n column, okay, and then whatever else you need. For the linear ones, it's the D, our D in this one is 25, times our n plus the initial value, or the P0. All right. And you can copy that one down too. Well, the thing is, if you're going to copy that one, what you have to do is the P0, you would have to make it an absolute reference. You have to put the dollar sign in. All right. You notice from 14 to 15, it went up by 25. Right. If we're going to drag it down, since I put the dollar sign in, it went up by 25 again. Both the explicit and the recursive get you the same answer. All right, let's come over to the exponential. And we have a similar thing going on. Your formulas are over here. I already have this set up in a recursive, so you can drag this down and get a few more of them. Okay. If you want another one that's going to be in explicit, what's happening in this one is the in an exponential, you'll see that in explicit, what you do is you multiply this 1 plus r, which it says is the growth multiplier, to the n power and multiply it times the original, okay, the initial value of the P0. Well, over here, the 1 plus n on this one is actually 1 plus r, I'm sorry, is actually 1.12. So if I do this, cell, is the arrow up. It's the uppercase on the number 6. My n here is just this number, is my x value, right? Oops, and I forgot, I'm sorry. We need to multiply that times our initial value. There we go. Okay, there's the next value. One last thing. At one point, you're going to be asked to use the formula that Excel gave you for the trend line graph to calculate another value. Now, so I copied this trend line number up here because it's hard to see and made it bigger. So here's the formula it gives us. Now, I notice the E. So E is really, it's nothing to be afraid of. It's just a special number, like pi is a special number for working with circles, right? Well, E is a special number that shows up a lot with exponential things, okay? So you can either use E directly, which I'll show you how to do in Excel in a moment, or the instructions tell us that we equals 1,000. Remember in Excel that we're going to times E, all right, times. Now in Excel there's a command to raise E to a power as EXP. All right, EXP, and then you open parentheses and you put the power in. So you notice the power here is 0.113x. So 0.113, I'm going to say times, and then pick a cell. Just click on that one. All right, now here's my cell that I put it in. So let me show you something here. So let me put 23 in here. All right. So that would be using the 23 for the x. All right, now what's happening here is this really should be the exact same as this, but because this only gave this to us to 4 decimal places, it's a little off due to rounding. If we had some more decimal places on our number there, 0.1133 and a few more, this number here would exactly match. It'd be the same thing. Okay, so let's look at the formula again. Our formula here says 1,000 times E to a power to the 0.113 times an x. So the formula here is 1,000 times EXP, open parenthesis, 0.113 times, and then put in a cell reference. I put in R22, right? Column R22, it's close, right? Close parenthesis. And then whatever you want to calculate, let's say you want to know in the year 30. Well, if I put in year 30 here, boom, now we're up to 29,006. All right, that's it for this one. I hope you find it helpful, and that is the last of the videos. It is now time to get going with your project.